When studying science, it's important to brush up on our math skills. In particular, there are a set of skills that apply only to science because the numbers that we use in science aren't just regular numbers, they're measurements. Measurements that have been made by humans using calibrated machines or by electronic devices that have been calibrated. All information in physics is based upon measurements of the world around us. In order to make measurements, we must define a unit that represents the quantity and then compare the size of a quantity to that unit. There are various systems of measurement that exist. For example, the imperial system, which is used in the United States and the United Kingdom. But the one that we use is known as the metric system, in a version known as SI, or System International. In the SI system, there are only 7 base units. All other units may be defined from these. The 7 base units include length, mass, time, electric current, temperature, amount of a substance, and luminous intensity. All other units may be derived from combinations of these base units. For example, area is measured in square meters, speed in meters per second, and force in newtons, which are equivalent to kilogram meters per second squared. When writing numbers and symbols in the SI system, there are several rules that you'll need to follow. Let's take a look at these rules now. Rule number 1. Always use the correct symbol for the unit. Note especially which are capital letters and which are lowercase letters. So 45 liters must be written using the correct symbol for the liter, which is a capital L, not a lowercase l. Rule number 2. Never put a period after a symbol unless the symbol comes at the end of a sentence. For example, 35 centimeters is written with no decimal at the end. Only include a decimal if it's at the end of a sentence. Note that centimeters is not an acronym that is separated by periods. It is a symbol, and the correct symbol is cm, both lowercase. Rule number 3. Never put the unit right next to the number. Always leave a gap between the two, about as wide as one number or letter. So we write 72 kilometers, and we make sure we leave a space in between the two about the size of one character or letter. Make sure you hit that space bar if you're typing in the number and the unit. Rule number 4. If a number is less than 0, always put a 0 in front of a decimal point. For example, 0.56 is the correct way to write this. We do not write 0.56. Make sure that you put a 0 in front of it, otherwise you're not following the SI system correctly. Rule number 5. Numbers greater than 9,999 always have the digits in groups of 3, with a gap, not a comma, between each group. For numbers between 1,000 and 9,999, the gap is optional. So look at this number here, 42,160 newtons. We add a space here, not a comma, and the space comes after this group of 3. For numbers in between 1,000 and 9,999, you don't have to put a space. It's optional. So if you put a gap or a space, it's fine, and if you don't, it's also fine. But for numbers greater than 9,999, make sure there is that gap between each group of 3 numbers. Rule number 6. Never use common fractions, always use decimal fractions. So in science, we don't write 1/4 liters, we write 0.25 liters. 0.25 liters is the correct way to write this measurement. I want you to practice the correct way to write each of these. Note, here's a little hint. Some of them are written correctly. Okay, so there's a couple in there that may trick you. Let's move on to scientific notation. Really big numbers and really small numbers are written more conveniently in scientific notation. Rules for writing numbers in scientific notation are as follows. Number 1, place the decimal point such that there is one non-zero digit to the left of the decimal point. Rule number 2, count the number of decimal places the decimal has moved from the original number. This will be the exponent of the power 10. Number 3, if the original number was less than 1, the exponent is negative. If the original number was greater than 1, the exponent is positive. Now these numbers will make more sense if we look at a couple of examples. Let's try the first example, 4,750,000. This is a big number. Your first step in writing this number in scientific notation is identifying where the decimal place is. In this case, the decimal place is not written, but it would be located right here at the end of the number. Now we want to move this decimal place to the right of the first non-zero digit as you read from left to right. Now that sounds kind of confusing, but let's look at it. A non-zero number is any number that is not zero. So if we read this number from left to right, the first non-zero that appears is the number 4. So our job is to move this decimal place to the right of the first non-zero. When you do, draw out the number of spaces that you move it. I always draw them out and I count them as I'm going. So if the decimal place is here after the last 0, I'm going to move it 1, 2, let me get this curved line, 1, 2, 3, 4, 5, 6 spots so that it's to the right of the first non-zero number. So we write 4.75, and we're going to multiply this by an exponent whose base is 10, and the exponent will be the number of spots that we've moved the decimal place, in this case to the left. So we moved it 1, 2, 3, 4, 5, 6 spots. So this becomes 4.75 times 10 to the power of 6. 4.75 times 10 to the power of 6 is the same thing as 4,750,000. It's written in a more concise way, but it also provides us with some information about the accuracy of the number or the measurement that was made. And we'll talk more about this in an upcoming section. Now we can also use scientific notation to write really small numbers that are less than 1, more efficiently on our page. And we're going to follow the same rules. We're going to identify where the decimal place is. And for numbers less than 1, the decimal place is already visible, so this is an easy task. But now we have to move the decimal place to the right of the first non-zero number that appears when we read from left to right. So the decimal place is here. I'm going to move it over 1, 2, 3, 4 spots so that it's to the right of the first non-zero digit, which is that 7. So we can write this as 7.89 times 10 to the power of, now we moved it to the right, so the exponent will be negative, and we moved it 4 spots, so the exponent will be negative 4. Okay, now here's a little rule that we need to know. When you move the decimal place to the left, the exponent increases. And when you move the decimal place to the right, the exponent decreases. The number of spaces that you move the decimal tells you by how much the exponent will go up or go down. Now I want you to try these examples on scientific notation. If you're using scientific notation in a calculator, you have to find your scientific notation button. And for most cases, the scientific notation button on your calculator will look like a button that says EXP. So your calculator can have a button that says EXP, or it can have a button that says EE, or it can have a button that says 10 to the power of X. Depending on the type of calculator you have, whether it's a scientific or a business calculator, you could find any one of these three different buttons. When you find these buttons, if you press it once, it's equivalent to typing in times 10 to the power of. So, if you wanted to write 7.5 times 10 to the power of 4 in your calculator, you would hit the 7 button, the decimal button, the 5 button, then you would hit your EXP, and then hit the number 4. So this one button replaces you typing in times 10 to the power of, which saves you 1, 2, 3, 4, or 5 keystrokes depending on your calculator. Okay, so it's a more efficient way to type that in. And trust me when I say this, throughout science, you'll be using scientific notation so often that it's important for you to start practicing how to type it in into your calculator. Okay, we're going to leave the lesson here right now and then come back and I'm going to teach you the next section.